Hello and welcome to this video brought to you by Smart Exam Resources. In today's video, I shall explain to you the concept of ionic equations. So now, let me tell you what ionic equations are. Well, ionic equations are equations that will show you the ions in the equation, the ions that are taking part in the equation, right? So now over here, let me first tell you what are ionic compounds. So ionic compounds usually are compounds or substances that will contain a metal and a non-metal. So first of all, let me just jot down the examples of ionic compounds. So when I talk about ionic compounds, the ionic compounds will contain a metal bonded to a non-metal. So it will contain a metal and a non-metal. Secondly, ionic compounds also include acids. So ionic compounds also include acids such as the hydrochloric acid, the sulfuric acid, okay, and also nitric acid you can include. It also includes ammonium compounds, and ammonium compounds, these contain the ammonium ions. So these ammonium ions are going to be present in these ammonium compounds, and ammonium ions, the formula is NH4 plus ions, okay. So now this is about the ionic compounds. So when I talk about ionic compounds, I mean a combination of metal and a non-metal. I also am referring to acids such as hydrochloric acid, sulfuric acid, nitric acid, or ammonium compounds which contain the NH4 plus ions. Okay. Now, many chemical reactions involve the ionic compounds, and when ionic compounds dissolve in water, the ions separate. I'm going to give you an example of one such ionic compound, which is, say, magnesium chloride. So I'm going to write magnesium chloride over here. Fine, just a minute. Okay, so I'm going to write magnesium chloride over here, MgCl2, and let us see how it separates into. It will separate into, okay, when I dissolve it in water, so plus AQ, when I dissolve it in water, is going to separate into Mg2 plus aqueous and also 2Cl minus aqueous. Now, okay, magnesium here, MgCl2 is a solid, so let me write the state of MgCl2. So it's a solid, okay. So now, one more thing I can tell you over here is, look at the bonding that is present in MgCl2. So if you imagine this MgCl2, you can just think about the atomic number of magnesium, which is 12, and the electronic configuration is 282, and chlorine is 287, okay. So now what's going to happen is, magnesium wants to lose its 2 electrons. At the same time, chlorine just wants 1 electron. So one of the electrons will go to one chlorine atom, and therefore there's going to be another chlorine atom. Obviously, you know the electronic configuration is 287. So the second electron is going to be given to this chlorine atom. So what is going to result? The resulting compound is going to be MgCl2. So that is how, when it is dissolved in water, you get Mg2 plus, because your magnesium, if you look at the magnesium, I'm trying to explain why it is going to be Mg2 plus and 2Cl minus. So this Mg on the whole is going to lose 2 electrons. So it is going to have a charge of 2 plus. So it's going to be Mg2 plus, okay. And there are how many chloride ions that are formed? Now when this is going to accept an electron, so if I just say that the first chlorine has accepted an electron, so I'm going to get, like over here I can say that I'm going to get 2 chloride ions with a charge of -1. So in all I'm going to get 2Cl minus, and therefore the equation is that when magnesium chloride, okay, which is a solid, is dissolved, okay, in water, it is going to give you Mg2 plus aqueous plus 2Cl minus aqueous. Okay, so this is the explanation for the above equation. Okay, so if you have this kind of clarity, you will be able to answer any kind of questions based on ionic compounds. Okay, the equations. Now let me help you to understand how to reduce a given equation into the ionic form. Okay, now for that I'm going to give you two examples. So let me just jot down the first example. And the first example is of barium chloride. See, and in ionic equations, if you write the state symbols, is going to really help you. So get into the habit of writing the state symbols. So I have barium chloride BaCl2 reacting with sodium sulfate, that is aqueous, so it's in solution, and then you get 2 NaCl aqueous plus BaSO4, and this is solid, right? So now I need to write this back into the ionic equation. So the first thing is I'm going to break every possible compound, okay, into its constituent ions. So now if you know the stoichiometry well, you will be able to see that BaCl2 is formed of Ba2 plus ions and Cl minus ions. But again, like in the previous example of MgCl2, you've seen that MgCl2 is going to break into Mg2 plus and 2Cl minus ions. Similarly, BaCl2 is going to break into Ba2 plus and 2Cl minus ions. Okay. Now trying to break this over here. Sodium sulfate. Now sodium sulfate, how many of sodiums are there? There are 2 sodiums. So the charge I'm going to get over here is 2 Na plus, okay, plus what? Okay, let me write the state symbols again over here. So this is going to be aqueous plus I'm going to get a sulfate ion, so that is SO4 2 minus and aqueous. Again I'll put a sign over here, so I need to put the signs in between, right? And plus, okay, and that gives me what? It gives me 2 NaCl. So I'm going to again break this NaCl into its ions. So I can maybe use another color here. Okay, so this can be broken down. Now NaCl breaks into Na plus and Cl minus, but since it is 2 NaCl, I'm going to break it into 2 Na plus 2 Cl minus. And coming to the last thing. Now last compound is barium sulfate, but as you can see the state symbol is a solid. So whenever something is in a pure solid form, okay, we are not going to break it into any of its ions because it's a solid, it is not in the ionic form. The state itself is telling us clearly. So I'm going to maintain this in the same way. So it is going to be written back as barium sulfate solid, right? Okay. I again forgot to write the state symbols for sodium and chloride. I'm just going to again write it down. So 2 Na plus aqueous plus 2 Cl minus aqueous. Okay. So now what's the next thing? Well, the next thing is to cancel out all the spectator ions. What do you mean by the spectator ions? Now I mean that there are some ions which are common to both the left and the right hand side. So I'm going to strike them out and I'm going to see which are those ions that are actually present on the left and the right side of the equation. I can see 2Cl minus and 2Cl minus are both present on the left and the right hand side. Also there is 2 Na plus and 2 Na plus present on both the sides. So now I can just write down whatever charges, whatever ions are present, whatever compounds are present that have not got cancelled. So now from the above equation, I can see on the left hand side barium ions, Ba2 plus ions. Okay, here again I have not written the state. So Ba2 plus, this is aqueous, this is aqueous. Okay, so Ba2 plus aqueous stays as it is, plus the sulfate ions SO4 2 minus aqueous gives you BaSO4 solid. So this is how we have written the given equation in the ionic form. Okay, so in the exam, if you have a question like this, do it exactly the way I've done it, and it becomes very easy. Okay, so remember how I've shown you in the above example how to break a given ionic compound into its constituent ions. I'll give you another example. Okay, the second and the last example, I mean. So now over here, suppose I take the example of aqueous solution of chlorine. So if I can just write that aqueous solution of chlorine as Cl2 aqueous, okay, if that is going to react with a solution of sodium bromide, so I'm going to write down plus 2 NaBr. It's a solution, so it's in the aqueous form, plus AQ, and that's going to give me Br2 aqueous and 2 NaCl aqueous. Now, what's the first thing? First thing is obviously I've written down the equation, obviously. Now the most important part here is to break every compound or a molecule that is given to me into its constituent ions. So I'm going to try and break down each of these. Now Cl2, what is the state of Cl2? Well, Cl2 is aqueous, but Cl2 is not broken down into an ionic form. Okay, so Cl2 is going to remain as it is. It's a diatomic pure molecule. So I'm just going to repeat Cl2 as it is. Why am I not breaking it down? Because Cl2, I know it's by default it is a diatomic molecule, right? So anything that is purely a solid or purely a gas, I'm not going to break it down into any kind of ions. Okay, so now plus 2 NaBr aqueous. Now 2 NaBr meaning there will be 2 Na plus, again state symbols are important, plus 2 Br minus aqueous, giving you, again Br2 is in the aqueous form and Br2 again is a gas. I'm not going to touch any of the gases. Okay, so it's going to stay as it is, plus 2 NaCl aqueous. Now since it is 2 NaCl, I'm going to write down plus 2 Na plus aqueous plus 2 Cl minus aqueous, right? Okay, now the next thing, remember the next step I had told you, just to cancel out the spectator ions. So what's common on the left and the right hand side? It is the sodium ions. Just cancel them. And last step is to write whatever has not been cancelled. And what has not been cancelled? Let me just see. So Cl2 aqueous stays as it is, plus 2 Br minus aqueous gives you Br2 aqueous plus 2 Cl minus aqueous. Aqueous. Well, isn't it really very easy? Yes, it's very easy. Always remember not to break any of the pure solids or the gases into ions. Okay, you cannot break them into ions. And next is cancel out the spectator ions, write the charges properly, and write your final equation, and you're sorted. Fine. So well, this is all in today's video on writing ionic equations and understanding how the formula for the ionic compound is also made. I just explained one example for the formation of that ionic compound of MgCl2 because the video was not based basically on how you're going to write the formula of ionic compounds. I explained it to you in the process, but yes, the main idea behind today's video was to help you to formulate the ionic equations, right? So, and in the exam these kind of questions are always asked, and children do not really know what is the meaning of, for example, over here if you can see, it is written Cl2 aqueous plus 2 NaBr aqueous. Children wonder what is this Cl2 aqueous. Cl2 aqueous means that Cl2 is dissolved in water, something like that. Okay, so it's a part of the aqueous solution. Okay, so it's difficult for kids to understand. Even in the above equation, if it is written Ba2 plus, look at this last equation here for the barium sulfate formation, this equation over here, Ba2 plus aqueous refers to barium ions in solution. SO24 minus aqueous refers to SO24 ions in the aqueous solution, okay, in the aqueous form. Now, if you understand the meaning of these state symbols, you will never ever find these kind of ionic equations difficult, because trust me, ionic equations are the easiest of all. Fine. So that's all in today's video on ionic equations, and if you like watching my video, please do subscribe to my channel. Thank you.